Saxon Advanced Mathematics, Lesson 71. The topic today is the ellipse. And John put a little 1 like that after the topic. That suggests to me there's more to come, but we'll just have to wait and see. All right, what even is an ellipse? Let's take this back. Do you remember how we've talked about the conic section, quote unquote? And that's the idea that there's this basic structure that lies at the heart of all these different shapes we've been studying. Oh, pretend that's the same top and bottom. That's not the same, but pretend it is. And this shape is made by holding a line at a point. I can illustrate it with my pen, right? It's holding, it's a line held at a point and then rotated. And if you do that in a three-dimensional way, right? If I draw a circle with the top of my pen, I'll get a shape that looks like that, right? This is the pen and it's being rotated. It's making a circle at the top and the bottom, and we're getting this X shape from the rotation. Now, remember I talked about how we pretend this is a butter sculpture? It's freezing cold, and we take red hot table knives and we cut through it. If we cut through evenly and then take this piece off and look at it, what we get is a circle. And I've drawn the circle on a graph to remind you that we can study it as a shape on a graph. And I also want to remind you that another way to draw a circle is to put down a thumbtack attached to a string and then attach a pencil or a green marker to the end of it. And if we just draw around, keeping that string tight all the way around, that is the way to draw a circle, right? Okay, so it has a central point and then a radius that goes all the way around and stays the same. Now, let's go back and get another butter sculpture out of the walk-in. When I was in high school, I worked in a restaurant, and I spent a lot of time in a walk-in. And this time, instead of cutting straight across, let's cut it at an angle. When we lift that shape off and look at it, what we're going to see is that the shape we make is not an even circle. It's what we used to call an oval. But now, because we're fancy, we call an ellipse. An ellipse is just an oval in sophisticated math words. Now, an ellipse can go sideways or it can go up and down. Either way, we're going to study both of those. One distinction I want to make is there's something called a major axis, which is the long one, and there's something called a minor axis, which is the short. All right, now I want to go back to this idea of the string, and I'm going to draw my ellipse going the other way so it fits in the space better. No, I'm going to draw it this way because I think it's easier to understand. When we draw an ellipse, we're still going to use a thumbtack and a string, but it's going to be a little different. What we're going to do is we're going to put down 2 thumbtacks and have a single piece of string between the 2 of them. It'll be looped, right? And what we do is we put our green marker and we into the inside of that string and we pull it tight. And then as we keep the string taut, the string will slip with our pen and allow us to draw, right? We're drawing to the extreme that the string will let us all the way around. Because we have 2 points instead of 1, we're going to get this ellipse shape, this elliptical shape. We call these 2 points the focus, or the plural is foci. We call this one F1 and F2. We're going to talk about these later in diagrams. And these 2 pieces of string, even though they're going to be changing in shape as we use our marker and pull around, we call them D1 and D2, D for distance. All right, so we're going to come back and talk about those a little bit more. These Both have the major axis on the x-axis, but we can easily draw them the other way as well, and we will in our problems. The formula, let me show up here. The formula depends on which way the axis is oriented. Make this one a little taller. This will be this kind of an axis, and this will be this way. In both cases, we always let A equal the major axis and B equals the minor axis. You'll see what I mean by this when you see the formulas. For this style, we'd say x squared over b squared plus y squared over a squared equals 1. So what we're saying is that the major axis is A, and that's associated with the y. So we put those two together. B is associated with the minor axis. That's the x axis in this point, so those two go together. Here, it will be just the opposite. X squared is associated with the longer axis, so that's A. Y squared is associated with the shorter axis, so that's B, and it equals 1. All right, so the formula depends on which way the ellipsis is oriented. All right, now we know enough to be dangerous, don't we? Now what I'm going to do is I'm going to draw a slightly more detailed picture. I'm going to draw it on this style, but it's on both, right? The details will transfer to both types. This kind fits on our paper better, let's be honest, right? Okay, so here's a nice big ellipse, and we're going to do some drawing on it. We know that A is the major axis, so this point we're going to call A0. Whatever this distance is from here to here, we're going to call that A. So this point would be positive A. When we go this way, it's also A. But over here, this will be negative A, 0. Notice that the center of our ellipsis is right on the origin. Now, we'll go this way. This distance is distance B. It's the minor axis, right? The shorter stub. And this point then would be 0, B, and then we go B in this direction as well, but this point would be 0 minus B. All right? So we can find these lengths, and we can use the lengths to identify the points. And for this one, the A is associated with the x, so this would be x squared over a squared plus y squared over b squared equals 1, right? We can take these values for A and B and create the equation. All right, let's try a problem. Now we really know enough to be dangerous. And there are 2 problems, that's all. Graph the ellipse, x squared over 25. Okay, so the first thing we do is figure out which way is this guy oriented. And we can see the larger numbers are on the bottom, right? These are squares, but this is going to be 5 squared and this is going to be 3 squared. So right away we see that the longer side is on the x. So let's draw accordingly. Your ellipse does not have to be perfect. Mine is clearly not. Okay, so we know that A must equal 5 because it's the square root of that, right? and B must equal 3. And this is one of those graphs where we don't have to chart it out. We're just going to say that this point, we know that this is 5, so this point must be 5, 0. And this point, because this is also 5, this point must be minus 5, 0. Now we turn our attention to the B value. B is 3, so this point must be 0, 3, and then this is also 3, and this is 0, negative 3. There's our graph. If we want, we can put an X here, and we can put a Y up here. We could put arrowheads on all these if we wanted to be fancy, right? I don't necessarily care if you put them there, but I do want you to remember that they exist, right? This is our origin. We don't have to label that. That's all we've got. This is important, and then these points. So there it is. We graphed our ellipse. Oh, fun, right? Okay, the other problem for this lesson, 71.2, says write the equation in standard form and graph the ellipse. Okay, so John's giving us something that's not ready. It's not graph ready. 5x squared plus 2x squared equals 15. Okay, this is not in standard form. There's no fractions, and this is not equal to 1. So what are we going to do about that? We will start by turning this into a 1. So we're going to divide it by 15, and therefore we're going to divide all of these by 15. All right. This clearly goes to a 1. Now, 5 over 15, this is going to cancel to a 3. And 2 over 15, this is going to cancel. Let's make it a decimal, 7.5. A decimal in the denominator is less offensive than having a fraction in the denominator. Then we'd have to go into complex fraction land, and let's just go to a decimal. So this will be x squared over 3 plus, oh, I copied something wrong. This is a y. Y squared over 7.5 equals 1. Okay. Cool. Now we're ready to graph. Now we can see the bigger number is associated with the y-axis. That means it's going to be this way. Our ellipse is going to be oriented up and down because the larger number is associated with the y-axis. Okay, remember we always call the larger side A. So A is going to be equal to the square root of that. I don't know that number. I know it's somewhere between 2 and 3, right? Because 2 squared is 4 and 3 squared is 9. 7.5 is between 4 and 9. But I'm going to grab a calculator in order to calculate the actual value, and it is 2.74. Okay, remember that we always round to 2 decimals in high school algebra unless you hear differently. Sometimes we go up to 3 or 4, but always at least 2. It's not harder to have more decimal places. It just requires a couple more flicks of your wrist. B is equal to the square root of 3. And I know that's going to be somewhere between 1 and 2, right? Because 1 squared is 1 and 2 squared is 4. This is in between. So we use a calculator again, and we get a value of 1.73. Rounded. Okay, so here are our 2 values that we're going to use. A value goes here, 2.74. So this is 0, positive 2.74. And this down here is 0, negative 2.74. And then this is our other value. Oh my gosh, that parenthesis went terribly wrong. 1.73. So this will be 1.730 and negative 1.730, right? It's not necessarily important that you put these measures on here. What we're mostly looking for are these 4 points, and these are correct. Yay, good job. Remember, once again, I want you to hold on to that picture that there are 2 points located about here and here. We're going to talk more about them in future lessons, and they have that string that attaches them, and we put our pen in right here and we pull that string around, and that's what creates the shape of this ellipse, right? We'll talk, like I said, we'll talk more about that next time. These are called the foci, plural of focuses. Focuses is not a word. And we call them F1 and F2. We're going to come back to those. So just imagine those 2 thumb tacks holding down that string. I like to imagine this on a bulletin board, that I've laid my paper on a bulletin board, and I can just push the thumbtacks through, and the string loops around. All right, guess what? That's all for today. We'll come back to this another day and add more to it, but for now, yay, we're done.